Good morning to all of you. I welcomes to all in our lecture series on solid state physics. In our today class, we are going to discuss about prediction of crystal structure information with the help of geometrical structure factor. In our last class, we have been discussed in detail about geometrical structure factor. So I suggest that before you have to watch today's video, you have to first watch this video, geometrical structure factor. And last expression of this derivation, we found that this one. So this is nothing but the total radiation scattered. This is represents the total radiation scattered by the scattered from the unit cell, from a unit cell will be equal to Fj. This is represents the atomic scattering factor, and this exponential term is represents the structural factor, geometrical structural factor. This summation over this exponential term will be represents the geometrical structure factor. So this is nothing but F H dash K dash is nothing but called as the total amplitude radiated, total scattering amplitude for the reflection H dash K dash A dash L dash. So if we have the amplitude, then we can easily find the intensity. So the intensity will be nothing but F square, F mod square, or the so called F into its complex conjugate. So up to this much we have been discussed in detail. You go through that previous video and watch carefully that video. If you not watched that previous one, then you have to watch. So here last class what we have been studied, that this is the nothing but our geometrical structure factor from which we can found the geometrical information important to determine the structure of the crystal or geometry of the crystal or geometry of the unit cell. Okay, so same thing in our today's note I have also written somewhat the previous discussions whatever I discussed now. That is, previously we found that the total scattering amplitude of a unit cell in general, it is F, capital F, H dash, K dash, L dash is nothing but summation over this much. Here Uj, Vj, Wj are the coordinates of the atoms. So this S, the exponential term, will be called as geometrical structure factor, and Fj is the atomic scattering factor of jth atom. So for our discussion here, we have been considered three lattice structures of simple cubic crystal. As per your syllabus, we have to follow this three crystal structure. It is inside your syllabus. So here we are going to be discuss about simple cubic, body center cubic, and face center cubic crystal structure. That means from this scattering factor we can predict or we can found that what will be the crystal structure. Suppose I am going to say that this is a unit cell. I don't know what will be it. It is a simple cubic or body center cubic or face center cubic. I don't know. But this is our incident X-ray. And this will be our diffracted or the so-called scattered X-ray. And from this scattered X-ray, I found this one, this much value. And from this value, I can predict that what will be its structure. It is simple cubic or body center cubic or face center cubic. That we are going to be discuss. So here one thing you have to remember always, in which way I am going to be predict the crystal structure. That is, we know that the intensity of the scattered radiation is nothing but mod square, amplitude mod square. So for which particular HKL, H dash, K dash, L dash value of the intensity will be maximum, only that plane is to be considered as the accepted scattered plane, where scattered radiation interferes constructively with each other. So we know that suppose this is a unit cell, and suppose simple cubic, I am going to say simple cubic So this is one plane, this is another plane. So incident radiation came over here and incidents and then diffracted. Okay, so when it is diffracted, these two rays can be constructively interfere with each other or can be destructively interfere with each other. If constructively interfere with each other, then it will follow the so called Bragg's law, 2d sin theta equal to n lambda, and this intensity will be found in our X-ray diffraction pattern. But if it will be destructive interference, then it could not be found in our X-ray diffraction pattern. So actually I am going to be say in your higher study you are going to be study those things. Actually if we are going to find out the X-ray diffraction pattern of a crystal, suppose this is a crystal material, I am going to take the X-ray of this material, then the output will be like this. Suppose this this is the angle of incident X-ray. This angle can be vary, and this angle can be vary 0 to 180 degree, that we have been studied. So from this X-ray pattern we can found that at a particular 2 theta, this is 2 theta, 2 theta is our this along x-axis. So this will be 20 degree, suppose 30, 40 like that. So at a particular angle the intensity will be maximum or minimum or maximum, somewhere like this. So this will be the intensity distribution of the XRD pattern, or this will be the so called XRD data of a crystal whenever it will be gone through the XRD verification or XRD study. So this will be the data. That means at a particular angle the intensity will be there, and this much angle there is no reflection or no intensity. So here you can see 30 degree is a higher intensity. Here from 30 to 40 there is no intensity. It is mean that in which angle, suppose 30 to 40, one angle you can consider 35. So in 35 angle, when it will be incident and diffracted beam are going to be destructive interference. So the incident for the 35 angle of the X-ray is produced destructive interference, hence we are not going to get any type of intensity. That things here I have been written that the intensity is much more important factor to predict that which plane is going to be accepted and which plane is not going to be accepted. Suppose from these are the two parallel planes. From these two parallel planes, if it will be constructive interference, then we can say this will be accepted, or this due to this constructive interference the intensity will be observed and it can be found in our this. If for a particular angle, suppose I am going to say 20 to 30 it will be 25. For a 25 degree angle diffraction will be always there, but they are going to be interfere with each other destructively, and we are not going to get any type of intensity at 25 degree angle. Hence that the planes or the reflection from those planes which are inclined with 25 degree could not be accepted. Okay, so this is the simple procedure that we have to accept to find out the planes present in the unit cell. If we can extract or we can know the planes and its arrangements, so easily we can draw the crystal structure. Now we have to first discuss about the simple cubic crystal. We know that the effective number of atoms in unit cell of simple cubic is 1. Let assume that that atom lies at the center of at the origin. Suppose that that atom, whatever the effective atom, considered at it is situated at the origin. That means the coordinate of that atom we have been taken as 0, 0 and 0. Okay, that means here the whole unit cell, this is the unit cell. Suppose this is a simple cubic have only one atom, effective atom 1. So this atom, suppose it is at the origin. Okay, That means if we are going to consider the atomic scattering factor derivations, this is the charge factor what we have been considered. This is a whole atom. So suppose it has one coordinate that is u dash v dash and geometrical structure factor. Yes, suppose if we are going to consider this will be the one charge particle, it has its own coordinate. Okay, so electron will be present at here at its own coordinate, and this will be the position vector. So here we assume that for a simple cubic, one atom is the effective atom, total atom in case of simple cubic is 1, and this is placed at the origin and having the coordinate is 0 0 0. Now this amplitude, total scattering amplitude in general will be written as this one. So I am going to put u v w j as 0 0 0, though it will e to the power 0 will be equal to 1, and I am going to get the scattering total amplitude of scattering. This will be f. The intensity will be f square. Here we have been consider the identical atom. So in our last class I have been discussed that if it will be identical, all the identical atoms if we are going to consider, then equation number 3 will be written as in the form of f into geometrical structure factor, f into s. So it will be, as it will be 1, the geometrical structure factor we found, that is exponent of this much will be 1, then it will be f and the intensity will be f square. This is equation number 1. This equation number 1 represents that all possible values of HKL, H dash, K dash, L dash will be accepted. That means here H dash, K dash, L dash, whatever the value we are going to be take, this value will be always equal to 1. So hence we can say all possible values of H dash, K dash, L dash will be accepted for the simple cubic crystals. So here for all possible values H dash, K dash, L dash satisfies H dash satisfies Bragg's condition. The line is incorrect. Satisfied Bragg's law. Satisfied Bragg's law or Bragg's condition. But peaks will be accepted or not, that depends on the intensity in bracket I, okay, of the scattered radiation. So sometimes what will happen that maybe constructive interference is going to happen from this by superimpose of scattered radiation. Sometimes constructive interference will be happens, but the intensity will be very less. Suppose intensity is this much. So if intensity will be this much, this could not be appear in the XRD data. So this things it has been written that maybe H dash, K dash, L dash, all the values of H dash, K dash, L dash will be accepted, but the intensity, if not that much, it could not be appear in the XRD data. So here H dash, K dash, L dash is means what? These are the coordinates, and it can be represented also by multiplied of common factor n with the Miller indices. That means H dash, K dash, L dash can be represented by multiplied of a common factor with the corresponding H, K and L. Okay, so this is the H dash, K dash, L dash is considered as your coordinates. However, it can be represented by multiplied with a common factor. That means H dash can be NH written as, K dash can be NK, like that. Okay, so this is the simple cubic things whatever we have been discussed, means all the planes here, all the H dash, K dash, L dash will be accepted, means all the planes, all the possible planes of the simple cubic crystals, when they are going to be diffract by the X-ray, they are going to be constructively interfere with each other, and they have to the information or the intensity has to become in the data. But if intensity is very less, it could not be appear in the data. But all the possible planes, whatever we can imagine for a cube, that can be acceptable for a simple cubic crystal structure. Now we have to consider body center cubic crystal structure. The effective number of atoms in body center unit cell is how much? Is 2. Okay. Now let us consider one atom occupies a corner of the position and other atom occupies at the center of the cube. Okay. Now if the coordinate of the center is 0 0 0, then the coordinate of other atom will be how much? 1 by 2 1 by 2 1 by 2. That we have been discussed at the time of coordination number. Whenever we have been discussed coordination number, that we have been discussed. So here see, here I have been taken all the positive. You can take all the variations. That means here can be plus or minus 2, plus or minus 1 by 2, plus or minus 1 by 2, means 8 possible corner atoms can be possible in case of body center cubic. So center atom is considered as 0 0 0 and another atom is considered as 1 1 1 here. Okay, for our discussion. So what will happen for total scattering amplitude? This is the total scattering amplitude. It will be F, because we have been taken considered as all the atoms are identical, so it will be F, and this is our structure factor, right? So here I am going to put we have two atoms here, so that means the body center cubic this is the body center cubic means the total atom in this crystal structure will be only 2. So one atom I have been considered over here at the center and another any of the corner. So if I will put the coordinates of these two atoms, then what I am going to found, see, so it will be uj, vj, wj is nothing but the coordinate of the jth atom, and it is over the summation. Then I am going to put first 0 0 0, then 1 by 2 1 by 2 1 by 2. It will be e to the power 2 pi I 0 0 0 0 plus 0 plus 0 plus e to the power 2 pi I half h dash plus half k dash half l dash, because here another coordinate is half half and half. So it will be e to the power 0 nothing but equal to 1 plus e to the power half. If we are going to take common, then it will be e to the power pi I into h dash k dash l dash. So this is nothing but what? Structure factor, right? This is nothing but structure factor, and this whole is nothing but the amplitude. This whole is represents the amplitude of the scattered radiation when the X-ray is incident over a BCC, whatever the scatter amplitude, total scattered amplitude is F h dash k dash l dash we found here. If this amplitude will be 0, there is no intensity. Suppose after diffraction through this crystal, the radiation intensity for a particular angle, the radiation intensity is 0. That means the reflected radiation from the particular set of parallel planes, when they are going to be scattered, they are going to be destructive interference. So hence intensity will be 0, or the so called amplitude will be 0. So if amplitude will be exist, obviously intensity will be exist, and that intensity will be accepted, or the corresponding set of parallel planes will be accepted. Okay, so here we can write, so and intensity will be this much. Okay, but we know that if this will be amplitude, intensity will be this much, but this HKL value, see here, it will be 2f value or 0 value. How it will be? See here, see, this is 1 plus e to the power pi I into h dash k dash l dash. Okay, now this value e to the power pi I h dash k dash l dash, suppose here h dash k dash l dash are the integers, so I can write this e to the power pi I h dash k dash l dash. So summation over by addition of h dash k dash l dash also a integer. If h dash k dash l dash is a integer, so addition of h dash k dash l dash also a integer. So it can be written as e to the power n pi I. So here e to the power n pi I is nothing but cos n pi plus I sin n pi. Sin n pi will be 0. Leave it. Cos n pi value will be either plus 1, cos n pi value will be minus 1. Plus 1 when n is even, when n is odd, this will be minus 1, whatever. That means we found the exponential factor. This exponential factor. See, this exponential factor, or the so called structure factor, either it will be plus 1 or it will be minus 1. So when it will be plus 1, then it will be 1 plus 1 equal to 2. So I am going to get, I can get f, the value will be maximum 2f. If this structure factor value will be minus 1 plus 1 will be 0, and we are going to get this value will be equal to 0. So hence I have been written over here that this value either be 2f or 0. So possible value of HKL what we are going to take, that this value will be or the structural factor will be 0 or 1. Let's see. First, now possible values of h dash, k dash, l dash we are going to consider, for which this will be equal to 0. That means when h dash, k dash, l dash addition will be odd. That I am going to, that I have been discussed over here. That here I have been taken n as nothing but h dash plus k dash plus l dash. So whenever this n will be even, then this will be 1 value, the exponential term will be 1. When n will be odd, the exponential term will be minus 1. So if minus 1 which is km, then this value will be equal to 0. So that means when it will be so when it will become as minus 1, when the n will be odd, or the so called h dash plus k dash plus l dash will be odd. When it will be odd, then it will be minus 1, and hence f h dash, k dash, l dash will be equal to 0. So this will be 0 when h dash plus k dash plus l dash will be equal to odd value. Example, you can take 1 0 0. 1 0 0 means 1. Okay, 1 0 0 means 1 0 0 equal to 1. So I am going to put 1. See, h dash, k dash, l dash is 1 0 0. So it will be e to the power pi I 1 0 0. So I what I found, e to the power pi I. So 1 minus 1 equal to 0. Okay, now you can consider 1 1 1 1 1 1. If you are going to consider, then what will the value of this exponential term? 1 1 1 3 3 pi I, 3 pi e to the power 3 pi will be equal to minus 1. So minus 1 equal to 0. So hence with example this etc. means addition of h dash, k dash, l dash, if odd, then the f value, amplitude of scattered radiation will be 0, and hence the intensity will be 0, and the corresponding these planes are not accepted, or we can say these planes are could not be satisfied the Bragg's law, or we can say these planes are could not be observed in our XID pattern, or we can say these planes are could not be accepted in BCC, or hence here it is written as hence diffraction from these planes of BCC will be absent. So if this type of planes we are going to be consider in HKL in body center cubic, then this planes could not be accepted because these planes could not be satisfied the Bragg's law. Now we have to consider the possible values of h dash, k dash, l dash, for which this will be maximum. The maximum value of this one is how much? 2f, that we have been discussed over here. When it will be 2f, then if this will be 1. When it will be 1, when h dash, k dash plus l dash will be even. Okay, same thing I have been written. So this value will be maximum, that is 2f, or the so called intensity will be square of this amplitude, 4f square, or h dash, k dash, l dash should be equal to even. So we can take the example 1 1 0. If I am going to take 1 1 0, 1 plus 1 is how much? Even. 2 0 0, even. 2 plus 2 also even. So for this planes, set of planes will be accepted for the BCC. So you can take one example, that is suppose 1 1 1. 1 1 1 means 1 1. 1 plus 1 plus 0 will be 2 pi e to the power 2 pi I. E to the power 2 pi I is nothing but equal to 1. So 1 plus 1 it will be 2f. Likewise for this one and this one we are going to get the value of this one will be 2f and the intensity of 4f square. That means hence the diffraction from these planes of BCC interferes constructively so that peaks will be present in X-ray diffraction pattern. That means in this data, if we are going to be consider the data of a BCC, these planes are belongs to like this one. This type of planes we are going to found, and this type of planes could not be observed in case of a BCC. Suppose this is a material belongs to BCC crystal structure, so I am going to be study of its XID pattern. Whatever the peaks I am going to be observed like this, like this will be the data you are going to be found after studying the XID. So this data, all the peaks, whatever the peaks, that peaks will be belongs to this one, this type of Miller indices, not this one. This could not be satisfied the Bragg's law. Now we are going to consider the face center cubic crystal. Now we have to consider the face centered cubic crystal, that is in this FCC crystal, the effective number of atoms in FCC will be how much? Total, that will be 4. Now let one atom among of these 4, consider one atom will be placed at the corner and taken as origin having the coordinate is 0 0 0, whereas other 3 are the contributes by the face centered having the coordinates 1 by 2 0 1 by 2 1 by 2 1 by 2 0 and 0 1 by 2 1 by 2. See, whenever I discussed about your coordination number, this is your body center cubic having 8 atoms will be nearby any origin has been taken. Suppose this will be the origin body center cubic in case of BCC, suppose this atom will be the origin, then from this the other nearby atoms will be 8 and the coordinates will be this much. So in this case we have been taken only one coordinate, whatever I have been discussed just now for body center cubic, that is 1 1 1 by 2 1 by 2 1 by 2. You can take any value of these coordinates, you are going to get the same answer whatever we have been discussed. Now in case of body center cubic, we found that the 12 atoms, the 12 atoms may be the so called nearby with one atom. But if we are going to consider the position or the coordinates of one atom to another nearby atom will be how much? It will be 1 by 2 0 1 by 2. See, the coordinates we have been discussed whenever I have been discussed the coordination number of FCC in our previous classes. So suppose from this, considering by these 4 atoms, 4 effective atoms, considering these 4 effective atoms, suppose one atom is at the corner, any corner, suppose here it will be, and here it will be, and other 3 will be suppose here and here and here. Then what will be its distance or coordinates from, suppose this will be the 0 0 0 and the coordinate of this one will be x axis half and y axis half, you have to move. So half 0 and other 2 like you can found that half 0 half like that. Now the diffraction amplitude will be how much? Diffraction amplitude will be in general is nothing but f h dash k dash l dash, in general will be how much? F into summation over this one. So if I am going to write then f into for the first atom it will be 0 0 0 e to the power pi I e to the power 2 pi I into 0 plus 0 hkl uj or you can say u1 v1 w1. If I am going to put 0 0 0 as for the origin, then it will be 0 plus 0 plus 0, and for others I can put half for this one, half h dash plus 0 plus it is 0, okay, means v is 0, v2 you can say v2 is 0 and half l dash. So this is suppose u3 v3 w3, so it will be e to the power 2 pi I half h dash plus half k dash plus 0 plus e to the power 2 pi I into 0 plus half k dash plus half l dash. Only I have been substituted the values of the coordinates, 4 coordinates, and I have been written in the addition form instead of summation. So if I am going to write elaborately of this summation by considering the 4 atoms and having their corresponding coordinates, then this will be this one. Now this will be e to the power 2 pi I into 0, then this value will be equal to 1 and this value will be, if I am going to take half as common, factor, then it will be e to the power pi I into h dash plus k l dash plus e to the power pi I h dash plus k dash plus e to the power pi I k dash plus l dash. Let this is equation number 3. Now this is nothing but is your f h dash k dash l dash. Detail I have been written in your note, but in your exam you can write in short. Okay, in short you have to write. See, you can compare for face center cubic and body center cubic. You can compare for body center cubic. For your understanding purposes, I have written all the equations, but here I have not mentioned the generalized equation. So like that, in the exam, for your exam purposes, as much as you can synchronized squeeze the writing. Okay, main points you have to mention. So here f h dash k dash l dash is nothing but will be the either 4f or 0. How? See, we have been just discussed that e to the power pi I, this will be a value of integer, because we know that h dash and l dash both are integer. So addition of this will be a integer, and this will be a integer, this will be also a integer, and we know that e to the power n pi I, e to the power n pi I, either it will be 1 or it will be 0. When it will be 1, when n will be even, just before we have been discussed, and when it will be 0, when n will be odd. That we know perfectly. So if it is so, then this value maximum will be 1, this value maximum will be 1, this value maximum will be 1. The maximum value of this will be how much? F into 1 plus 1 plus 1 plus 1. That will be 4f. That things I have been written over here. So f h dash k dash l dash will be the either 4f, that will be maximum, or it will be 0. Because if suppose we are going to consider this will be odd, minimum, I am going to think about the minimum value. Suppose this will be the odd. Suppose for this term n is odd minus 1, and this term n is odd minus 1, and this term n is even plus 1 minus 1 plus 1 minus 1 will be got cancelled, then it will be 0. Okay, sometimes you can found this will be the odd and this will be the even and this will be the also even. So the 1 plus minus got cancelled and you are going to get the 2f. So maximum, I am telling about that maximum value of this will be 4f and minimum value will be 0. That means the value of HKL for FCC will be vary from 0 to 4f, and corresponding intensity will be how much? Maximum will be 4f square, that will be 16f square. Okay. So for a particular h dash k dash l dash value, e to the power n pi I will be 0. These things I have been discussed here. I have also written for your understanding purposes. Here I have been also written. You have to write in your note that you can understand whenever you have to study your note. So these things I have to remove. No problem. Because these things I have been written here, because as e to the power n pi I will be 0 when n equal to odd and 1 when n equal to even. Now we have to consider the possible values where this f will be 0 and this f will be 4f. See, it can be found that the structure factor in this equation number 3, the structure factor of this equation number 3, suppose this is the equation number 3. Okay, the structure factor of this equation number 3 is how much? This one, this much is atomic scattering factor of single atom. And as we are considering the identical atoms, so it will be f, and this whole is nothing but so called s, that is called a structure factor. So in the equation number 1 will be accepted for all even or all odd values of h dash k dash l dash. Here 0 is also considered as even. Okay, so that means it is telling that if we have to consider either h dash k dash l dash, either all r should be even or all r should be odd, then we are going to get the maximum value of this scattering factor will be 4. Let's check it out with an example. Suppose we are going to take, and remember that 0 is considered as a even. These things you should not be write in your exam. Okay, these things you should not be write in your exam. In short you have to write and you have to give one example. It is more than enough. So reflection from 1 1 1, suppose we are going to consider the plane 1 1 1. Now the structure factor in the equation number 3, what will be the, see, h dash 1, k dash 1, l dash 1. See, h dash, l dash, 1 1 2, e to the 2 pi I will be equal to 1. This will be e to the power also 2 pi I will be equal to 1, e to the 2 pi also equal to 1. So you got the 4. Okay, intensity also 4. Now you consider all, this is all odd. Okay, you considered that reflection from 0 to 2 0 0, that means all even means also s will be 4. See, here h dash is 2, kl is 0 0, so h dash is 2 pi I 1. So here h dash is 2 pi I is 1. Here h dash is 0 0, 0 0 means e to the 0 equal to 1. So you got the s equal to 4. Okay, now structure factor in equation number 3 will be vanished. Now these are the accepted things. Either you have to consider h dash, k dash, l dash are all even or all odd. Now what will be not accepted? Now the structure factor in equation number 3 will be vanished. When it will be vanished, then the corresponding h dash, k dash, l dash could not be acceptable. That means we can consider, we can accept it that the corresponding the so-called Miller indices, this h dash can be represented by a multiplied with a integer h, no? So also this is nothing but also it's a synonym of, you can say synonym of the either way representation of the Miller indices. So if structure factor of this equation number will be vanished for any h dash, k dash, l dash, that means that from that plane whatever the scattered radiation is coming out, that is interferes with each other destructively. So what will be the possible values of HKL? That is that mixed values of h dash, k dash, l dash. That means it will be vanished. The structure factor this in this equation number 3 for in case of FCC will be vanished when h dash, k dash, l dash will be mixed. That means it has to be mixed of odd and even. Mixed of odd and even. Suppose you can take an example 1 2 0. Here 1 is odd, these two are even. So for this type of planes could not be acceptable in FCC. How? Why? Because structure factor will be 0. Let us check it out. 1 2 0 h dash, k dash, l dash. So h is 1, l is 0. So it will be -1. Okay. H dash is 1, 1 2 0. H dash is 1, l is 0. So e to the pi I will be -1. So this will be h dash, k dash. H dash, k dash. H dash, k dash means 1 plus 2 will be 3 pi, also -1. And then k dash, l dash. K dash, l dash means k dash, l dash, k dash plus l dash will be 2 pi, will be +1. So +1 -1 +1 -1 got cancelled, structure factor will be 0, and the corresponding so F1120, the amplitude of scattered radiation from this plane is 0, because from this plane could not be the scattering radiation from this plane could not be satisfied the so-called Bragg's condition, or you can say that they could not be interfere constructively if the radiation is coming from this plane. Here I written dash, no, this is 1, this is 1, this is not dash anything. 1 2 0, this plane only I have been written over here, this plane here. Okay, similarly you can consider another mixed planes, that is 1 0 1 1 0 1 1 1 are the two odd and this is 0. You can check it out, that structure factor for FCC here. If you are going to put 1 0 0 over here, then you can find also it will be 0. You check it. Okay, next 1 0 1 0 0, if you are going to put, also you are going to get structure factor will be equal to 0. Okay, this is all about our discussion about geometrical application of geometrical structure factor, how geometrical structure factor has been used to find out the lattice, the different crystal structure. As per your syllabus concern, it has been discussed. We have been discussed simple cubic, body center cubic, and face center cubic. Likewise, in your higher study, you are going to be find out for other crystal structure like hexagonal structure, monoclinic structure, triclinic, other structures can be calculated, but it will be somewhat complicated. But in our BSc syllabus, this much is enough. You go through this video properly, carefully, watch it, and if in doubt, wherever you can contact with me, we are going to be discuss. And here one table format I have been written for you, that you have to remember always. This will be most important. This table or whatever we have been discussed, in short I have been written. That you have to remember, because these conditions is most important, always asking in your competitive exams. What we have been discussed, that SC, remember, important. I told, okay, that is for simple cubic, reflections allowed for the possible values of all possible values of HKL. So here I have been written in general form, because we are discussed h dash k dash l dash, because h dash k dash l dash is the another way of the representation of the, maybe the h dash k dash is the l dash is the correspond, it represents the coordinate, but it is also represents the another way of the corresponding Miller indices. That means h dash is nothing but nh, k dash is nothing but nk. Okay, so n is only the common factor, nothing else. So all possible values of HKL can be accepted for simple cubic, but for body center cubic only even values of H plus K plus L. Suppose we have a plane having the Miller indices H, K, L, and I am going to add these HKL, and if I am going to get the even, then that HKL is going to be possible for the FCC. If I found H plus K plus L will be odd, that plane, suppose I discussed over here 1, 2, 3, I am going to take one plane. 1, 2, 3, 3, 2, 5, 1, 6 is even. This will be accepted for the BCC. Okay. Suppose I am going to, but this will be not accepted for the FCC, because this is the mix of odd and even. This is the mix of odd and even. Okay. So now I am going to consider 200 plane. 200 plane means 2 plus 0 plus 0 is even. It will be accepted for BCC, and this also accept for the FCC, because in case of FCC all odd values or all even values will be accepted. All odd or all even values of HKL will be accepted. So these things you have to remember perfectly and go through this video. If any doubt, we are going to be discuss. So thank you so much for watching this video. Thank you.